I'm Stephen Sass, Professor of Material Science Engineering at Cornell, and in the study room today I'll be talking about how materials have helped shape our world, starting with the Stone Age and coming back up to today's world. And some of you might wonder, since I'm a scientist and engineer, how I got involved in something that involved not only science and engineering, but history and, you'll see eventually, art. Well, it all began some years ago when I was teaching an introductory course in material science to my sophomores. I was at a particularly boring point in the lecture, and I could see I was putting the students slowly to sleep. And of course, professors don't like that, so I put my notes all aside and I decided I'd begin telling some anecdotes to wake them up. I said, you know, it's kind of amazing. If you took a bar of high purity iron, you could take it and bend it over your knee, and it's very weak. But if you take some charcoal out of your backyard grill and sprinkle it in, you can transform it into high-strength steel. How would New York City look, Tokyo, Shanghai look without high-strength steel? And I can tell, looking at the class, they had begun waking up. This wasn't the hard science I was discussing, but something more interesting. And I decided to plunge ahead with this. I said, you know, 4,000 years ago, iron was much more valuable than gold. If you wanted to give a very valuable gift to a pharaoh or a king, you gave an iron dagger, not a gold dagger. This got me thinking, perhaps I could make my field, material science, accessible to a large number of people by basically embedding what I did in an historical context. It'll also give me a chance to show lots of beautiful works of art, as you'll see. This would also make what I did accessible to my wife and my two sons, who are in the arts, not in science and engineering. So I set out to write a book called The Substance of Civilization. That's what I'll be discussing today. Basically, how did materials help us become what we are today, help shape our civilization? And along the way, you'll see that we're going to learn certain things that might help from the past, that might help us today. We'll discover that shortages drive innovation, and this may be very, very useful as we address the problems of today's world where we want to do something about sustainable energy. We'll also discover that materials tend to be a disruptive technology. When they come along, major revolutions can occur. This will happen later in my talk. Okay, with that in mind, let's begin at the beginning, and I think I'll really first show you a chronology because we're going to cover a lot of time and a lot of space. The Stone Age began roughly 2 million years ago, plus or minus a few 100,000 years. The modern era, or the end of the Ice Age, was about 8,000 BCE, before the Common Era. The Bronze Age, about 3,150 BCE. I like to weave in occasionally references that many people know about, so I'll bring in things from the Bible. Abraham, Isaac, and Jacob were roughly 1750 BCE, but I have to point out there's no hard facts about that. It's in the Bible, but there are really no hard facts about that. But since we all know about it, I'll use it. The Iron Age was roughly 1200 BCE, and interestingly enough, Moses and the Exodus occurred roughly at the same time. We'll see there's probably some link with them. And I have to say again, of course, that while Moses and the Exodus is in the Bible, there's no hard evidence for that. Alexander the Great, 330 BCE, and Caesar Augustus rules Rome, 0, the time of Christ. Well, as you can see from my chronology, historians have named eras after materials. So we'll begin at the Stone Age, then we'll get to the Bronze Age and the Iron Age. So what did artisans do? They found stones, and they began shaping those stones into things, simple tools like hand axes. And they then began using obsidian. That is nature's glass. This is the chunk of obsidian my son Eric found in the deserts of southern Idaho. Idaho, the southern part, is covered with lava. Volcano explosions occurred. And they also produced this nature's glass. And the key thing for us is that you can shape it into very sharp edges. A friend of mine looked at this and said this was shaped by somebody, so it was probably used to scrape the inside of a pelt, a very simple tool for cleaning the inside of a pelt. But with obsidian, you could begin making more sophisticated tools and weapons, such as arrows and spears. And with arrows and spears, hunters could now go after much larger animals. They could kill at a long distance. And so one of the consequences of this is that certain species went extinct. The giant cave horse in Africa and the woolly mammoth. So the fact that we today wipe out species, unfortunately, that's been going on for a very long time. Whenever there's an advance in technology, there are positive aspects and negative aspects. Now, you can see here an arrow. This is not an old arrow. It's actually quite new. But this, you can see also it's very brittle. Glass, we know, is very brittle. The tip's broken off. We're going to have to work this problem out. Eventually, we're going to want to replace this with another material, and we're going to have to worry about that later on. Okay, what's next in our story of materials advances that made possible our world? Well, artisans began taking clay out of stream beds, and they recognized they could shape objects and fire them in kilns. The earliest known object is a Venus figure from the Czech Republic from 24,000 BCE. It's about a 3 or 4 inch high object. It's clearly some kind of fertility figure used in religious rites. The key thing here is that you can now not only shape these kind of figures, but start making containers. If you wanted to have containers for liquids before this, you had to shape them out of stone. Not very, very easy to do. So folks began making ceramic pots. The earliest known ceramic pot is from the Jomon period in Japan, roughly 10,000 BCE. We also have various beautiful works of art from China. And this is an amphora from 4,500 BCE. This is from the area of Bampo, which is close to Xi'an. This is a rather beautiful pot. A little later, we have these Neolithic pots from the Majao culture, 2,500 BCE, again from China. So we have now ways to make containers we didn't have before. With ceramics from clay, humans learned for the first time that the physical properties of materials could be changed and dramatically improved by heating. You could sometimes make them 1,000 times stronger or stiffer. This was first done with clay, but we do it all the time today when we want to make high-strength steel, when we want to make aluminum for various applications such as jet aircraft. It all began with firing ceramics. Now, the firing of ceramics to make containers was very critical because that, together with the development of agriculture, allowed large cities to be developed. Wild wheat was first domesticated in the area of Jericho, just south of Jerusalem, and that was roughly 8,000 BCE, and Jericho was a town of about 2,000 people. Wild wheat was then taken up further north to Anatolia, present-day Turkey, and there was a city called Çatalhöyük, a city of 5,000, established roughly 6,000 BCE. But the first large cities sprang up far to the east, area we call Mesopotamia, the land between the Tigris and Euphrates rivers. And these large cities came about in the southern part of Mesopotamia, which is present-day Iraq. Clay could be used for the storage not just of food and drink, but also the storage of information. The first writing was in the form of cuneiform tablets on clay. They were developed about 3150 BCE in the city of Uruk, in the southern part of Mesopotamia. And they were developed for something which we would consider perhaps mundane today. When a farmer was growing crops and brought it into the city, he wanted to get credit for it. He didn't trust memory anymore, and he wanted a written record. So the first writing is really for storage for information about crops. When a farmer had valuable land close to the river, he also wanted a written record of his deed. Those are the first uses of cuneiform tablet. Now, if you want to carry the theme of storage even further, if we extracted silicon from the clay, we could, of course, come up with our silicon chips today, which is the basis of our computers, cell phones, HD TVs, things like that. Now, if you're living in southern Mesopotamia and you wanted to build something, you had very little to use except mud and clay because there were no trees there. This is an alluvial plain, very flat plain. So we see here a ziggurat, a temple mount, which is made of clay bricks. Top of these would be where the religious priests are, a bit closer to heaven. And the farmers would bring their crops into these temple mounts and, of course, get record for that. Now, when we want to talk about writing, we understand how important it is. For example, the science I do. If I do Science Significa, I write it up, publish it, and it's sent to other parts of the world, England, Japan, China. People try to reproduce what I did. They either succeed or not. And this gives rise to a dialogue. That's a very important part of doing modern science. So we can't imagine that without a written record. We also can't imagine our life without a literature. And the first early writings that were put down was actually the Epic of Gilgamesh, put down around 2000 BCE. It had been transmitted orally before that, and then it was finally put down in a permanent form. We're now going to move on to another material. Remember I showed you an arrow that had a broken tip because glass or obsidian is very brittle. What's the next material that we want to talk about? And that would be metals. So artisans would find chunks of copper in stream beds, very small pieces of copper, and they began shaping them into jewelry and beads. Not anything more useful. The problem was you wanted to get a lot of copper for things like arrows, spears, plows, axes. And how'd you do it? You had to learn how to extract copper from ores. Nobody knows how that first happened. So of course this gives me a chance to tell my story, and I can make some comments about that. Here is a piece of copper. It's not from the stream bed, but this is what we want to get. And this is a chunk of malachite. This is a beautiful semi-precious mineral that's used for jewelry today. The key thing for my story is that this has plenty of copper in it. But these don't look very similar. How would you extract copper from malachite? Well, the way you'd have to do it is you'd have to carry out what's called a reduction reaction. You would heat this up with charcoal, carbon. That would compete with the copper for the oxygen, pull it away, and leave behind metallic copper. That's all well and good, but how did it first happen? Well, my version of the story is this, that a potter wanted to decorate a clay pot with a piece of malachite, stuck it in the side of the pot, put it in the kiln, fired the kiln, and of course what might have happened is that the malachite fell to the bottom of the kiln where the reduction reaction occurred. Did it happen that way? Nobody really knows, but it's a pretty good story. And you can imagine the potter when he or she cleaned out the kiln and found, my goodness, a chunk of copper. Well, this happened roughly 4000 BCE, and this gave rise to the use of copper in a large variety of ways. Well, what could artisans do with this new material, copper? They could produce beautiful works of art, and one of my favorites is the Judean Desert Treasure. It's from the 35th century BCE. It's currently in the Israel Museum in Jerusalem. And one of the more spectacular objects is this crown, which was poured in one piece by the lost wax technique. And this is what's interesting, is that this was a one-piece object with all those little figures on it. This is the same technique that's used today for producing single crystal turbine blades for jet aircraft engines. But this was developed 5,500 years ago, and this is nearly 2,000 years before the historical part of the Bible. It's rather amazing what kind of technology was around back then. This was involving copper arsenic alloys, and it's very important when you're using copper to add something to it. We call that alloying. It turned out that nature produced copper arsenic ores, and this was what people first used. But there are problems with that, because if you're dealing with a liquid that contains copper and arsenic, the arsenic begins sublimating, begins coming off. It's very bad for your health. And so the Greek god of metalworking, Hephaestus, was lame, probably because of arsenic poisoning. The Roman god, Vulcan, was also lame, probably for the same reason. Now, when we're dealing with copper, we're going to see a problem arising. And every so often, problems will come along, and we're going to recognize what they're going to lead to. In antiquity, it took 7 kilograms of wood to make 1 kilogram of charcoal. You basically take wood, begin burning it, and then you smother it, and you burn off all the resins and leave behind, basically, carbon. It took 20 kilograms of charcoal to make 1 kilogram of copper. You multiply it out, 140 kilograms of wood, 1 kilogram of copper. Advanced materials take a lot of energy. And you can imagine what mining sites look like. There'd be a ring of desolation spreading out across the countryside as you chop down all the trees. Now, I couldn't find any pictures back 4,000, 5,000, 6,000 years ago, but I did find one from a 16th century German mine in a book that was translated from the Latin by Herbert Hoover and his wife. Herbert Hoover, who was the 28th president of our country, was a very successful mining engineer and a scholar. And he and his wife translated this book in the early part of the 20th century. And in this is an etching that shows you a German mine with most, but not all, of the trees cut down around the mine. So this is a warning for the future. Advanced materials take a lot of energy. Well, copper arsenic ores finally ran out, and people looked around for something else to add to copper, and they discovered that tin would be very useful. And so the next important alloy was a copper tin bronzes. And this, of course, not only was beneficial for making materials stronger, it also improved people's health. The Chinese excelled at producing very large bronze objects. I have a small one in back of me. This is a bronze Fang Hu. This is a wine container from the Han Dynasty about 2,000 years ago. One can imagine this, if it was really polished up, to be a spectacular looking bright yellow color. Okay, now there are other metals around besides copper and bronze, gold and silver. I want to talk briefly about that. And so if I'm a scientist and an engineer, and I'm always puzzled why people were so interested in gold and silver, because they were very soft and they had really no practical use. But of course, if you wanted to use them, you could turn out beautiful works of art. And one of my favorites is this gold head covering from the city of Ur in Mesopotamia, 2600 BCE. This was taken from a warrior's grave. And if you look closely at it, at the top of it, you'll see beautiful details of the hair. Again, this was 1,000 years before the historical part of the Bible. There was remarkable technology back then. If everyone believed that gold and silver had a certain value, it did have one important use: for coins, for currency. Before we had coins and currency, all trade was done by bartering. Supposing I had some lapis lazuli, and someone else had wheat, and I wanted their wheat, I'd give them lapis lazuli. They might not want my lapis lazuli. You'd have to trade it to a third person or a fourth person. It made trade and commerce very difficult. If we had something which everyone believed was important, was valuable, then of course this facilitated trade. And one of my favorite coins is this tetradrachma from the city of Athens, showing the Owl of Athens. As we approach the end of the second millennium BCE, about 1200 BCE, another problem is going to arise. People had learned to put tin in copper to make bronze, but you had to import the tin from some distance away from the eastern Mediterranean. And that might be the area of Iran, up on the mountains. But what was happening then, there were mass migrations of what were called the Sea Peoples from southern Europe into the eastern Mediterranean. And these folks overran the Hittite Empire in Anatolia and wiped it out, almost destroyed the Egyptian Empire. Of course, when this is going on, one of the consequences of this is that all long-distance trade routes break down. So there was a shortage of tin for bronze, in fact, and of course people needed bronze then to make weapons to defend themselves. So we have a shortage emerging. At the same time this was going on, Moses was leading the Hebrews from Egypt around to what was called Palestine. And he brought them into Palestine up in the hill country. And they were up there because down on the coast, the Sea Peoples had come in, they were called Philistines, and they occupied the plain. So we're going to have to sort that problem out later. But right now we want to address the problem of the shortages of metals such as bronze. And one thing we've learned is that shortages drive innovation. People start looking around to find something to replace what they don't have. And they began discovering that there was another metal around called iron. Now the iron they found was in the form of meteorites, small chunks that they knew came from the heavens. And they called, of course, iron names such as black copper from heaven or heaven metal. The problem, of course, is that there's not much in the way of iron in the form of meteorites, and you need a lot of iron to make something useful. It took quite a while to learn to extract iron from ores. Again, you have to heat the iron ore up with carbon and to carry out a reduction reaction. I found some interesting numbers that tell us exactly what was going on. In the 19th century BCE, 40 grams of silver bought 1 gram of iron. By the 7th century BC, when people learned to extract iron from ores, 1 gram of silver bought 2,000 grams of iron. So in 1,200 years, the price of iron fell by a factor of 80,000, and basically there was a revolution on your hands. It took 1,200 years, and we assign the Iron Age to roughly 1,200 BCE. What's kind of interesting to me is how everything was linked together in the 1200s. There was turmoil in the eastern Mediterranean, there were shortages of tin for bronze. This gave rise to iron, and meanwhile, this might have facilitated the exodus of Hebrews from Egypt, even though they perhaps could have have had help from on high as well. Now, with cheap iron, it was possible now to make better tools and weapons. Northern Europe was settled because people had iron axes and iron plows. Of course, the armies of the day also benefited, the Assyrians and the Romans. In fact, the Romans had the best steel workers of the day in Toledo, Spain. So when they were fighting up north against the Gauls, that's in present-day France, the Roman legions had steel blades, while the Gaul warriors had wrought iron blades, which are soft iron. So whenever a Gaul warrior's blade struck a Roman blade, it bent. The Gaul warrior had to stop, take the blade, bend it over his knee, straighten it out to continue fighting. Of course, he didn't survive very long. What's next in our materials that made possible our world? Remember, I showed you how we could take clay and make it into ceramic pots. That's very, very good, except it takes a while to do that. You would shape the pot, you would let it dry, and then you would put it in the kiln for perhaps a day or so. Is there a more efficient way and a more quick, rapid way to make containers? So we're going to turn now to glass. The earliest glass was in the form of small containers, pots that are found in, or cups that are found in pharaohs' tombs. This is one from the 15th century BCE. It's made by a process called core forming. Basically what you did is you made the inside of the cup with clay and dung, put it around a post. Then you took a chunk of glass and you pulled out some glass from it. It's like taffy. And you'd wrap it around. You could just get it hot enough to do that. Let it cool, clean out the interior, decorate it, and you came out with beautiful cups in all small amphoras. But these were very expensive things to make. They were suitable for kings and pharaohs, but not for folks like you and me. We have to find a way to make them much more quickly and much cheaper. And so I have to tell you a bit of history. The Babylonians overran Israel in 587 BCE. This was a tough place to be living, where the Hebrews were in Palestine. So the Babylonians overran that, and the Babylonians exiled the Jews from their country to Babylon. And we know this from two things, from Psalm 137 of the Bible, and showing my age, I know it from the Simon and Garfunkel song, By the Waters of Babylon. Though my students would never know that, to be honest. Well, what happened? This was a tough place to be living. And the Persian king Cyrus defeated the Babylonians 50 years later. He was slightly more enlightened, so he sent the Jews back to Jerusalem with the admonition to rebuild their temple. But they also carried knowledge of hotter kilns because the Babylonians had discovered how to make hotter kilns. This is very important for the working of glass because now the kilns are hotter, you can make the glass more fluid. And this allowed the development 500 years later of glass blowing in Sidon along the Lebanese coast. This happened about 50 BCE. And basically with glass blowing, what you do is you take an iron pipe, you take a gather or gob of glass, blow on it, make a bubble, and you've got your container. It doesn't take a day, it can take a few minutes. So this really was a remarkable advance. Basically, the glass blower's breath replaced the core and core forming. This is a simple and elegant solution to a problem, and it gave rise to a revolution in the working of glass. You could also produce great works of art, beautiful works of art. And there's a very beautiful cup called the Lycurgus cup in the British Museum from the 4th century of the Common Era. And this turned out to be one of the early uses of nanotechnology. Basically, this cup was produced by sprinkling a little bit of gold and silver into glass. In transmitted light, the cup looks like ruby. In reflected light, it looks like jade. So when we think about nanotechnology, it's been around for 1,600 years, though of course people didn't understand what they were doing back then. Glass today is very high technology, and one of the high technology applications was produced just down the road from Ithaca in Corning, by the Corning Glass Works. They invented high purity glass fibers, which is the basis of the information superhighway. This was first done in 1970. Well, glass, we know, is used in many other ways as well. I have glasses, and so the glass is used for the lenses. Glass was also used for lenses for microscopes and telescopes, opening up the heavens and opening up the microscopic world. Well, towards the end of the 5th century of our era, Rome fell for the last time, and after that, perhaps for another 1,000 years, not a lot happened in Europe when it came to materials. Advances were occurring, but they're occurring far to the east in China. Out of China came paper and printing and gunpowder, cast iron, cannons, silk, and porcelain. So let's start with paper. The Chinese had been used to taking old clothing, heating it up, stirring it. They would then break up the clothing into fibers and deposit on a mold, which they lift out. They had like a felt-like surface. You would peel it off and rub on it, and you develop paper. The Chinese also used printing, and some of the earliest printing were Buddhist figures. The Chinese as well invented movable type. And this was a very novel approach, but of course it didn't benefit them as much as it would folks far to the west, where we have an alphabet. But the Chinese used movable type, and some of the earliest printings were, the most well-known one is the Diamond Suture from 868 of the Common Era, found in Dunhuang. The Chinese also invented cannons and gunpowder. So before this, they had rockets where they used their gunpowder. They closed off one end of the rocket with bronze. They stuck in the gunpowder, stuck in the rocks, and as you can see, you produce grape shot. Some smart person said, why not use a smooth ball? And the first cannon was produced, roughly about 1200 of the Common Era. So we owe a great deal to Far East. It was interesting that all these advances went west via trade and warfare and were rapidly improved on, but when they went back to China, the Chinese didn't accept these advances up to very recently. Well, we're now moving closer to our world now, and we have cannons invented, and people had been using cast iron to make them. And if we get closer to our world in the 15 and 1600s, the British excelled at producing cannons. In fact, they did so well that there was a great market in smuggling cannons out of England to the enemies. And so when the Spanish Armada set out in 1588, most of the cannons on board had been produced in England. With good luck or bad luck, depending on which side you were, the Armada never made it to England. Well, now we have a major use for iron, and that is cannons. And what we're going to find out is that England began running out of wood to produce the iron. There was a timber famine in England in the 1600s because wood had been used for making charcoal for producing iron, baking, beer making, and building the ships of the British fleet. So there was a shortage of wood in England in the 1600s. Luckily for England, they had carbon in another form, in the form of coal. Now, coal has a problem. If you ever smell coal being burnt, the smell you get off is from the sulfide compounds coming off. What you don't want if you use coal to produce iron, you don't want sulfur to get into the iron. It makes it very brittle. And so it's very common for cannons to explode. So unfortunately, a Scottish king got his head blown off in 1490, standing next to an exploding cannon. It took the early 1700s and an iron worker named Abraham Darby discovered how to take coal, begin burning it, smothering it, and burning off all the impurities, leaving behind something largely as carbon, which we call coke. So thanks to Abraham Darby, it was possible to now use the coal to produce iron ore. This Darby family was quite extraordinary. They ran iron foundries into the 20th century in England. Abraham Darby's grandson, Abraham Darby III, was the first to cast girders. What he built in 1779 is still standing. It is an iron bridge at a place what the English called Iron Bridge across the Severn River in England. By looking at this bridge, you can realize you're seeing modern construction because all those girders are going to be used in the future for building modern buildings. We use today an internal skeleton based on these girders or an endoskeleton to build with. It goes back to 1779. Okay, we now have a way to extract iron ore, but the problem is most of the coal that's going to be used for doing this is not on the surface, it's down in deep mines. And problems will begin emerging because what happens in deep mines? They flood. So England faced a difficulty. They wanted to pump out the mines. How could they do this? This led to the invention of the steam engine by Newcomen, first and then improved upon by James Watt sometime in the 1700s. And if we now look at a drawing of the steam engine, the advance of James Watt was to put an external condenser in. What's interesting to me is that if we look at a diagram showing a sequence of events, it's very striking. The shortages of wood lead to the use of coal, and there's a need to pump out the mines. This led to the invention of the steam engine, which was the primary source of power for the Industrial Revolution. But the story is much richer than that. The mine owners wanted to bring together coal and iron ore, so they built canals in England. And some smart mine owners said, well, let's put down wooden rails and have carts pulled by horses to bring the ore and the coal to the canals. Some smarter person said, well, let's use an engine to pull that cart. And this gave rise to the invention of railroads in the early part of the 19th century. Well, railroads involve heavy engines. And so when people used wrought iron rails, very soft iron, there were problems with that. So in the London train system in the 1850s, these wrought iron rails got squashed out of shape in 6 months. You had to rotate them 90 degrees. You can imagine doing that today in New York City or London or Shanghai. It's not going to work. Of course, what this gave rise to was development of ways to produce large quantities of high-strength steel. And much of the use of steel in the 19th century is for putting rails across Russia, Europe, and the United States. But the story goes even beyond this. This is what I like about this, that a French scientist named Carnot wanted to improve the efficiency of the steam engine, and he began developing a field which we call today thermodynamics. Thermodynamics today is much more important than just making engines more efficient. We can tell whether chemical reactions will occur because of thermodynamics, as well how to get to very low temperatures. Also emerging out of a steam engine would eventually be the internal combustion engine, the gasoline engine, towards the end of the 19th century. All this came out of a shortage of wood. So this leads me to the point that I made earlier in my talk, that shortages drive innovation. And what's special about this is that when we try to solve the problem of a shortage of wood, no one could imagine what would come out in the end. So this gives us hope for the future. And I wrote about this in an op-ed article for the New York Times, but they called it Scarcity, Mother of Invention. I'll say shortages drive innovation. But basically, when you set out to solve a problem, you might get results that are much beyond what you could ever imagine. This perhaps is an optimistic view of the world as we address our problem today of trying to develop sustainable energy. But this has worked in the past. It might work that way in the future. Now, materials in general tend to be a disruptive technology. When they come along, they create revolutions, and I've made these points all the way along. There are many examples of this, but one of my favorites comes from the American Civil War. That was back when the South had put iron plates on a ship and gave rise to the Merrimack. At the same time, the Union was building in a Brooklyn shipyard the Monitor. They came together, they fought each other to a draw. There's a well-known quote from the London Times. The battle between the Monitor and the Merrimack on March 9, 1862, revolutionized naval warfare, in one day making all wooden men of war obsolete. The London Times reported that the day before the battle, Britain had 149 first-class warships. Now they had only 2, both of which were iron-plated and probably no match for either the Monitor or the Merrimack. So this is a good example of how a material has a very disruptive effect on technology. Of course, the British immediately began making iron and steel warships. Materials and how you process them really drive innovation, and I've used the word revolutionary technology, so it happens again and again. One of the modern ways, of course, was the development of ways to put transistors on silicon single crystals. This gave rise to the integrated circuits that we use for our computers, cell phones, and everything else. Well, our long story starting from the Stone Age up to the Industrial Revolution is coming to an end now. I have many, many stories to tell that remain about the last 200 years where the scientific method came into play. That's involving Lavoisier and Priestley and many others. But that's the basis of another study room. If you're interested in more of these stories, you can find them in my book, The Substance of Civilization.